natural numbers are called multiplicative inverses if when you multiply them together you get the multiplicative identity 1. Now some matrices also have a multiplicative inverse, and with matrices, if you take a matrix that has a multiplicative inverse times its multiplicative inverse, you get what's called the identity matrix. Now the identity matrix is a square matrix. It has as many rows as columns, and it has ones down the main diagonal. The main diagonal is starting in the upper left-hand corner and going downward, and zeros everywhere else. So the identity matrix for a 1 by 1 is just the element 1. The identity matrix for a 2 by 2 would have 1, 0, 0, 1. So notice ones down the main diagonal, zeros everywhere else. The identity matrix for a 3 by 3 would be 1, 0, 0, 0, 1, 0, 0, 0, 1. Now if I can find a multiplicative inverse for a matrix, if I multiply them together, then they would get the multiplicative identity matrix of the size that matches their dimension. So when does a matrix have an inverse? Well, first of all, even to have a chance of having a multiplicative inverse, the matrix has to be square. So that means it has to have as many rows as columns. But even square matrices, just because they're square, doesn't guarantee that it has a multiplicative inverse. Not all square matrices have a multiplicative inverse. When we're looking at the conditions that have to be met in order for a square matrix to have a multiplicative inverse, if you're further on into the theory of matrices, there is a check that you can do to see whether that square matrix has an inverse before working through the process. Since this video is targeted towards just an entry level with using sum of matrix operations and the multiplicative inverse to solve systems of linear equations, we're going to find out if our square matrix has an inverse by actually going through the process to try to find it. And then as we're going through, I'll talk about, well, what might occur in that process of finding the multiplicative inverse that would then show you that, hey, this matrix does not have a multiplicative inverse. Now, in order to go through the process, we need to recall our 3-row operations for matrices. So our legal 3-row operations for matrices are, you can multiply any row by a non-zero constant. So you can multiply any row through by a number as long as that number is not 0. The second one is you can interchange any 2 rows. So if you have full rows and you want to switch their spots with each other, that's a valid row operation. And then a third row operation is you can add a multiple of any row to another row. And kind of preface that with, you can add a non-zero multiple of any row to another row. Now, where these row operations are going to come in handy and be necessary for the process is to find the multiplicative inverse by hand of a square matrix, if it exists. We set it up by starting with the matrix. So we'll write our 2, 1, negative 1, 2, 2, negative 1, negative 1, negative 1, 1, that they want us to find the matrix or the multiplicative inverse of. And then we put a dashed line and we tack on the identity that matches the size of the matrix we started with. So if we were finding the multiplicative inverse of a 2 by 2, we would tack it on with this one. But we want to find the multiplicative inverse of a 3 by 3, so we're going to tack on the 3 by 3 identity. So 1, 0, 0, 0, 1, 0, and 0, 0, 1. Now I'm going to use the 3-row operations, different combinations of them, to transform this left side of the dashed line into the identity. And if I can get it into the identity where I have the ones down the main diagonal and zeros everywhere else, And as I'm transforming it with the row operations, I do the row operations all the way across the full row. Then if I can get that as the identity, this right-hand side is like a bookkeeping of the row operations that we did and the ordering in which those row operations occurred. So this right-hand side actually transforms into what the multiplicative inverse matrix is for the original one you started with. So now let's see what we can do. When we're going through the process, it's very important to be systematic about it so that you don't mess up earlier work by getting too far ahead of yourself. So you want to do the process from left to right, and from left to right you want to use your row operations to get the 1 where it belongs in the goal matrix, and then the zeros. And after that first column's cleaned up, then you want to get the 1, then use multiples of that row to get the zeros, and then get the 1, and then get the zeros. So unfortunately, even though there's a 1 way over here in the third row, third column already, that's something I don't want to distract me, because it's way too far into the process to think it's going to stay that value. So we'll deal with that as we go, because we need to go from left to right so that what we do in later things don't mess up our earlier work. So going through this process, we want to have a 1 in this upper left-hand corner. Now right now it's a 2. I could multiply the entire first row by the multiplicative inverse of 2, which is 1/2. So if I multiplied this 2 by 1/2, I'd get 1. But then 1 times 1/2 would be 1/2. And -1 times 1/2 would be -1/2, etc. So I'd get fractions really early in the process. And while I wouldn't get the wrong multiplicative inverse at the end if I did that, I would have fractions to work with, and so it would just give me more situations where I might make a mistake. I see that in this first column, in the third row, I have a -1. And I know I can interchange rows. So if I just take row 1 and interchange it with the opposite of row 3, then that's going to give me a +1 up here, because the opposite of -1 is +1. Now I'm going to keep track and symbolize the operations that I do underneath the matrices at each stage, just so if I make a mistake, I can go back and see where it was and fix it. So this is the symbolization of interchanging rows. So I'm going to take row 1 and interchange it with the opposite of row 3. So I'm going to put the opposite of row 3 in row 1 spot. So that's going to be the opposite of -1 is 1. The opposite of -1 is 1. The opposite of 1 is -1. And then my dashed line. The opposite of 0 is still 0. The opposite of 0 is still 0. And the opposite of 1 is -1. And then I'm putting what used to be row 1 in row 3's spot, because I switched them. So down here in row 3, I'm going to write 2, 1, -1, 1, 0, 0. Notice I think about what I'm going to do with my row operations by focusing to the first column, second column, etc. But I do the row operations all the way across. And I focus on the columns to decide what to do, but the row operations are how I accomplish that task. And then row 2 didn't get affected in that stage, so we are just going to copy that down. So I got my 1. Now I want to use multiples of row 1 to add to rows 2 and then later to row 3 to get the zeros in this spot. So if I look at right now as a 2, and I want to know what multiple of row 1 can I add to row 2 so that that would be a 0. Well, if you get your 1 then your zeros, what you're multiplying by is always the additive inverse of what number's sitting there. So the additive inverse of 2 is -2. So I'm going to take -2 times row 1 and add it to row 2 to replace my row 2. When you're doing that, add a multiple of one row to another row, the row that gets replaced is the row that was added to. Okay, so what we're going to do also here is just rewrite row 1, because it is what we want it to be at this stage. And now I'm going to take negative 2 times row 1, and I write that on scratch paper. I don't do that in the matrix. I write it on scratch paper, so I just replace the row that was added to. So negative 2 times row 1 would be negative 2. Negative 2 times 1 is negative 2. Negative 2 times negative 1 is positive 2. And then 0, 0. And negative 2 times negative 1 is positive 2. Add it to row 2. So I'm going to put my 2, 2, negative 1, 0, 1, 0 underneath, and I get 0, 0, 1, 0, 1, 2. Then I still need to get a 0 in the row 3 first column slot, and that is also a 2. So I'm going to take negative 2 times row 1, add it to row 3 to get a new row 3. So that gives me negative 2, negative 2, 2, 0, 0, 2. And I'm taking negative 2 times row 1, added to row 3 to give me a new row 3. And then I write my row 3, which is 2, 1, negative 1, 1, 0, 0. And I get 0, negative 1, 1, 1, 0, 2. So notice column 1 is exactly the way we want it. Now we want to come down the main diagonal, and I want to get a 1 sitting in this next diagonal down slot. Right now it's a 0. There is nothing you can multiply to 0 to make it a 1. Anything times 0 gives me a 0. So then I look at rows below it. Never switch with rows above, always switch with rows below. And I look at the row below it, and in this row below it, I have a negative 1 sitting in that column. So if I, kind of like what I did in the first step, if I interchange rows 2 with the negative of row 3, I'll get a 1 in that spot. Now notice my row 1's not going to be used in that step, so I will write it in first so I don't miswrite the other rows as we go in. Okay, and we're taking row 2 and interchanging it with the opposite of row 3. So the opposite of row 3 is what I'm going to write in row 2's slot. So I'm going to write 0, 1, negative 1, negative 1, 0, negative 2. And then I'm interchanging the opposite of row 3 and row 2. So the opposite of row 3 is what I wrote in row 2's slot. Row 2 is what I'm going to write in row 3's slot. So that's 0, 0, 1, 0, 1, 2. 0, 0, 1, 0, 1, 2. So my first column's good. My second column has the 1 where I want it. And now I take multiples of row 2 to the other rows in order to get the zeros here and here. Well, I already have a 0 in the second column, third row, so that's good for this stage. I'll just go ahead and write that over here in row 3. I have the 1 in the second column where I want it, so I'll write that second row in over here because it's good at that stage. And then I want to get a 0 here. It's a 1 sitting there. The opposite of 1 is negative 1. So I'm going to take negative 1 times row 2 and add it to row 1 to get a new row 1. So negative 1 times row 2 added to row 1 gives me my new row 1. And whenever you're doing these row operations, you're doing them on the current rows that you have. You never look too far back into the process. It's where you are currently working. So, and your multiple of your row added to another row, you always do that on scratch paper and then put the replacement in the row that it got added to. So negative 1 times row 2, well, negative 1 times 0 is 0. Negative 1 times 1 is negative 1, and that would give me a 1 and a 1 and a 0 and a 2. and I'm adding that to row 1. So that's 1, 1, negative 1, 0, 0, negative 1. So we're going to double check this. Negative 1 times row 2, added to row 1. So that gives me 1, 0, 0, 1, 0, 1. So now when I look at my first column, still good, because I did it in that order from left to right. It didn't mess up my first column. My second column now is completely fixed. So now I'm going to go into the third column. I want to get the 1, and it already is a 1. That's good. We're very fortunate that that's a 1 right now. Let's talk about what would happen if it weren't. Let's say that it ended up that that was a 0 there, and now there aren't any rows below it. Well, then I would have all zeros to the left of the dashed line in the bottom row. That's a situation where that tells you that your original matrix was not invertible. So that original matrix does not have an inverse if that occurs while you're solving it. Now let's say it were another number that's not 1, but is also not 0. So let's say it were 5. Well, then I would just multiply this bottom row by 1/5. And then that would give me 0, 0, and then the 1, etc. So that's how you can fix that if it's not a 1. But it is, so that's good. And I'm going to write that third row in the next stage because it's good for where we are in the process. And I want to get a 0 in the third column in the rows above it. And remember, always use the multiples of the row you just got your 1 in. Add to the rows that you're trying to force your zeros. So negative 1's inverse, additive inverse is 1. So I just want 1 times row 3 added to row 2 to get me my new row 2. So 1 times row 3 added to row 2 will give me my new row 2. So I have 0, 0, 1, 0, 1, 2. Add it to row 2, 0, 1, negative 1, negative 1, 0, negative 2. And I get 0, 1, 0, negative 1, 1, 0. For my second row there. And then I look in that column and it is a 0 above it in my row 1, so my row 1's good. 1, 0, 0, 1, 0, 1. So I was able to get my 1's down the main diagonal, 0's everywhere else, so I was able to transform the left of the dashed line into the identity. So that means that my original matrix is invertible, and its multiplicative inverse is the matrix that's now to the left of the dashed line. Notation-wise, when I want to say that I have the multiplicative inverse of a matrix I started with, I look at what the name is of the matrix that they had me start with. This is matrix A, they called it. And so the notation to say, hey, I've got the multiplicative inverse of that matrix, I say the same name, capital A, and I put the little negative 1 up and to the right. So for that matrix, A inverse, the multiplicative inverse of it, is this 1, 0, 1, negative 1, 1, 0, 0, 1, 2. So if I were to take and multiply this multiplicative inverse matrix I just found times the original matrix, I would get the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. So that's one way you can tell whether you have the right multiplicative inverse, is multiply it times the original matrix and see if you get the identity matrix. And while it's absolutely important to understand that in general, multiplication for matrices is not commutative. If you switch the order of multiplication with matrices, sometimes you can't even do the matrix multiplication if the order is switched, or you most generally won't even get the same answer. So you have to always do your multiplication in the order that it's presented or that it is defined in a process. It is true for certain pairings of matrices. If you change the order, you do get the same answer, but it's just a select few. It's not like a general thing that we can say. It is true with a matrix and its inverse, that if you take the matrix times the inverse, you get the identity, or if you take the inverse times the matrix, you get the identity. So that does work with either way. Now, in another video, I show how you would use this multiplicative inverse to solve a system of linear equations. So I'll have the link to that in the description. Before we end this video, I just want to mention that if you have a TI-84 or TI-83 calculator, then you can enter this information into your TI-83 or 84 calculator and have it calculate the matrix multiplicative inverse through the calculator options. But it is important to know how to do these row operations for later things as well, or for Gauss-Jordan elimination if you're solving a system of equations using that process. So it's best to just use your calculator if you're running really short of time, or as a double check to see that you get the correct value. Now with these calculators, the matrix is your second button, and the X with the little -1, it says matrix above that. So if you push the second button and that key, you will see that it says matrix, and then it will give you names, math, edit. To put the original matrix in, you're going to cursor right to, and I know you can't see the screen, I just want you to see where I'm pushing on the board of the calculator, to where it says edit, and just push enter after that to be able to edit into a matrix. Now the first thing it wants you to say is what's the dimension of the matrix. So this is 3 rows by 3 columns. Remember, you always say your horizontal count rows first and then your vertical count columns second. So you're going to have, you push 3 and then cursor over 3 and then cursor down, and then it gives you enough slots to put in your numbers. So then if you push 2 and enter, 1 and enter, -1 and enter, it just pops through all of the entries to fill in those numbers. Now once it fills them all in, you have to get out of the editing mode of the matrix menu in order to be able to do the rest of the process. So if you notice right next to your second button, there's a button that says mode, and above it, it says quit. So you push the second button and the quit button to get out of the matrix entry mode. And what I want the calculator to do is to take that matrix I entered and find the multiplicative inverse. Sometimes the key I'm going to talk about is misnamed. Sometimes people call it the reciprocal key. It is not the reciprocal key. It's the multiplicative inverse key. So when I use the multiplicative inverse on a number, I will see a reciprocal because that's how you do that for numbers. But if I want the multiplicative inverse of a matrix, notice none of these are reciprocals of those numbers. It's not that definition to find the multiplicative inverse of a matrix. I have to go through this to get it. So if you look at then going second and that multiplicative inverse key to get back to the matrices, and the very first option is names, and it's highlighted on that very first one where we entered matrix A. So just push enter to pick it, and then push the multiplicative inverse key without pushing the second, just push the key, and it'll put that -1 and then as the symbolism on it, and then push enter. And when you push enter, you'll see this matrix show up on your screen. So again, that's how you can get it from your calculator, but be careful. Don't get too dependent on your calculators. They should always be a tool and not a crutch. I hope this video was helpful, And again, watch for other videos where this is applied to a process, or other operations of matrices, algebra, statistics, trigonometry, whichever those types of concepts that you're looking for extra help with, I have uploaded on my channel.